with dynamic geometry. Dynamic geometry said, yeah, dynamic geometry, dynamic something for sure. Yeah, dynamic geometry. So with dynamic geometry, right here, they're saying they said a minor arc AB. So minor arc means a smaller arc. So you have a circle, right, and then you have a smaller arc. So there's A here, B there, the minor arc, the smaller arc. It says it subtends angle ACB. So this is A, there will be C somewhere here, there will be B somewhere here. Or rather, what we can actually just do for ourselves is let's just draw the circle first, you know? Because if we have the circle, we can easily do and put all these things that they want us to put. Even make it a big circle because why not? You know, the bigger the better. So they said AB is a minor arc. So you have point A here, you have point B here. So with this being said, your minor arc looks like this. So with this minor arc, they said it subtends the angle ACB. So there's C over here, there's A over here, there's B over there. So you obviously have this angle there. Make this a bit bigger. So you obviously have this thing here, this thing here. Now, with all this being said, they said, yeah, ACB subtends ACB at a circumference such that triangle ABC is an isosceles triangle. So this triangle here, we actually need to modify this a bit then, so that it's like, you know,
It
it
should be
looks a
by
bit,
the radian.
not necessarily, just we just need to at least show that these lines are equal, like line AC and well, we don't know which ones are equal actually, so that's gonna be interesting because they said here such that triangle ABC is an isosceles triangle. So we don't know if it is these two angles that are equal or these two angles that are equal or these two angles that are equal. We'll soon find out. And then it says here and CAB. CAB is equal to 62. So this is like 62. And then they said here the same arc subtends ADB. So you have ADB, right? So you have A here, B somewhere there, and then B here, like that. And then they said here, oh, to the left, subtends ADB such that D is on the left of the point C. Wow. I feel like I should read better and then make a sketch. So D is going to be somewhere there. And then they said here, do this, let's do this. And then they said here, D, D, C is equal to 20. So this here is equal to 20 degrees. So the thing is, when they told us that we're dealing with an isosceles triangle here, we need to be careful. We need to be careful which angle we're going to make what you make. We're gonna which two sides we're going to make equal to each other. But the thing we can use to help us is the fact that these are equal to each other, right? These are equal because they're angles subtended by the same chord or arc. Yeah. Now, what we know is if these two are equal, and what we also then know is this angle is 62, right? So this one here is bigger than 62. So if this angle here is bigger than 62 plus the 20, what am I thinking here? I'm trying to find a way to properly determine which of our lines here are going to be equal to each other, because if you mess up there, or rather if we mess up there, we might find ourselves in a bit of a mess, you know.
Why don't you just um why don't you just add the 20 with the 62?
What do you
Sorry,
mean by
and the minus the 60 minus the 20 from the 62.
to do what? Oh wait, you're
Hmm?
saying okay? What? No, what I'm trying to say is we are trying to figure out, remember they just said this is an isosceles triangle. They didn't say which of the sides are equal to make it an isosceles triangle. You see, it says AB subtends angle ACB at the circumference such that triangle BC is an isosceles and CAB is equal to 62. Then it says the same arc subtends ADB at the point at such that point D is on the left of the point C. Then it says DB, wait, DB, oh, I made a mistake, bugger. They say DBC, so it's DB and C is equal to 20. This is the angle that is equal to 20. See, so what I was saying is the conflict here is which ones do we assume are equal? Is it these ones that are equal to each other? Or is it these ones? But I think a fair bet would have been to say the 62 is equal to this angle, because I mean, like, if these are equal to each other, right? If this is 62 and this is 62, it means that this would need to be 62. And yeah, that just feels a bit weird. But it doesn't necessarily feel a bit weird. I don't know. It's possible. It's possible because this is 62 and this is 62. This here would need to be like 56, the whole angle there. This whole angle would need to be 56. Meaning this would be 20 and this small angle here would be like 46. So the only problem is really determining which of these sides here are going to be equal to each other, because they just say this is an isosceles triangle. But it looks like push is coming to shove here, and we'll just have to choose which ones are equal, because it's just a 50-50. It's a 50-50 guess, actually. Oh no, not a 50-50. It's more like a 30%, because you're gonna, if we choose these two to be equal, then these angles are equal. If we choose these two to be equal, then these angles are equal. If we choose these two to be equal, then these angles are equal. So do you see the dilemma?
Yeah.
Yeah, me too. Me too.
But
Me
okay.
too. Me too. Me too.
What if?
Hence,
Oh no, never mind. That won't work.
And a.
Hmm?
Yeah, I was reading the questions. Well, in this situation, right? I mean, like, we have the answer at the back of the book, right? So we'll just make our decision and then we'll check the back of the book.
Can I just let you know now? The back of the book, the answers are not always correct.
Oh, true. But at least if we do what we do and they match, then we're safe. If they don't match,
Okay.
then there are two things involved.
Okay, let me check then.
Oh yeah, you can maybe tell us what answers are there so we know what to expect.
Okay, so the supposed answer is 82 degrees and 56 degrees.
82 and 56. 82, yeah, so okay, fine. Let's just put that there so we know. This one is the 82 one, right?
Mm.
And this is 56. Okay. Okay.
Mm-hmm.
It's fine. We have is done it. We're fine. We can move on.
Mm-hmm.
Yeah. So yeah, let's do what we need to. Let's do what we need to do. So doing what we need to do, we're going to say these ones are the ones that are equal. You know, let's just do it. If we say those are the ones that are equal, fine. It says calculate B, D, A. Yeah, it doesn't look like that would work, because if BDA is 80, no,
Oh, let me tell you.
no,
Let me
it's the
tell
other
you.
one.
Let me tell
Oh,
you.
hey.
You
Oh
see,
yeah. Oh yeah, it
angle.
is 20. Oh yeah, this is
Oh,
20
okay.
angle
You saw.
subtended. Oh no, it was mental telepathy. It was mental telepathy because the moment you were about to say it, it jumped into my brain because my brain was like, what is she about to show me? And then your brain was like, the 20. And then my brain was like, oh yeah, of course the 20. That's how we're gonna figure out which one is so what? Yeah, the 20, we got the 20. Thank you very much. So we have the 20. The 20 is somewhat going to make our life a bit easier because that's how we are able to see that BAD is equal to 82. Perfect.
Mm-hmm.
And then angle ADB, the angle there, we can just get angle C. You see? Now, the way we're going to get angle C is, fortunately, if this is 56, it means, well, this is almost like forging the question because, well, whichever way, our assumption would be correct because if this one here is 62, right, this one here has to be 42.
Mm-hmm. Two.
And if this one is 42, it means that C, but 180 minus 62 twice, this is going to give us 56. And then we know that D, right, is equal to angle C. The reason is angles subtended by the same chord. Angles subtended by angles in the same segment. There we go. Angles in the same segment. And then now what? Can I say therefore D is equal to 56 degrees also.
Degrees.
There we go. There we go. So this was not so bad. It was
Yeah.
annoying, yes.